So, good morning to everyone. Today, we will see first the switching techniques, which I have been discussing in the previous class about the switching techniques. And already there are three types of switching techniques present: packet switching, circuit switching, and message switching. Already in the previous class, I have discussed the circuit switching and message switching. The one type is remaining, that is the packet switching. First, we will discuss it, and then I will start the OSI model, Open System Interconnections model. So first, before starting the OSI model, the packet switching, the last switching techniques which is used. And in this switching techniques, the message are broken up into the packets. So the total message are broken up into the packets, and the individual packets take different route to reach the destination. So if there is a length of message, the message is broken into parts. So this part will become an packet. So this packet will take different route to reach the destination. So what is the advantage of this? The advantage of this is required bandwidth is reduced. Now the bandwidth is reduced because the total message is broken into packets. So the bandwidth will be reduced. And if any link failure, then the different routes can be chosen for remaining packets. So that if the link fail, then sender also send the data to the destination using some different routes. So how it can be? There are two types of packet switching. One is datagram packet switching, and another one is virtual circuit packet switching. So first we will see how a datagram packet switching works. Now here in this diagram, you are seeing that there are the systems. Total 4 systems are present. A, B, C, D, all the systems. And between them, there is a communication medium. Now in this communication medium, you can see there are different routers and switches present in the communication medium. This is for a communication medium, there are different routers and switches present. So now if we see from this diagram, if A system wants to send data to the D system, then how it can be sent? Now in packet switching, we have know that the message, whichever is to send from source to destination, is divided into parts. And after dividing into parts, it became the packets. So this is the message. You see, this is the message that A system want to send the D system. Now, this message is divided into parts. This message is divided into, here I have divided this message into 3 parts. So our message become 3 packets. So the message is divided into 3 parts and it becomes 3 packets. So now you will see these packets one by one will be reached to the destination. Now, first there is the one packet, number 1 sequence packet. This takes the route, this takes this route from this node to this node, then from here, then it goes to the D, then it goes to the D system. So first packet reached to the destination. Then the second packet takes this route, and from here it goes to the D system. Now there may happen that it is divided into packets and the packet takes the different route to reach the destination. So there may happen that the sequence number can be changed. Means the first packet reached the destination. It's okay. But the second packets take a longer route. The second packet takes a longer route, and to reach the destination, it takes time. In between, the third packet also started its journey, and it takes the small route rather than the second packet. So in the receiver side, the third packet reached fast, but the second packet reached later. So here the message sequence changed. You see the message sequence is changed. So for this reason, in the receiver side, there is a logic present for reassembly of the packets. This will done that the sequence order, this will again change it that as a sequence number that is present in the original packet when it is in the sending the original content will again be reassembly of packets through logic. Reassembly of packets will be done during the D system. So because D is the receiver, so in receiver side, what the message the sender sends the packets in the sequence of 1, 2, 3. But what have the second packet takes the longer route, and for this reaching the second packet, our third packet get first reached to the destination, and the second packet reach after it. So the sequence order is changed. The sequence order of the packet is changed. So the original packet sequence that is present on the receiver side is not now present in the destination side. So what we will done in the receiver side, there is a logic present, reassembly of packets. This will reassemble the packets in the sequence order again. So that's how datagram packet switching works. So here it is written that now packets 1 take a route but reach its destination first. But packet 2 takes a longer route. So the reason packet 3 reaches the destination before the packet 2. But it is not a problem because we know the sequence number of each packet, and in the receiving side, reassembly of packets are done. So the packets are arranged according to the sequence number. So that's how a packet switching works. Means a message, if the message length is big, the message is divided into packets, and these packets will take different route to reach the destination. And after reaching destination, there may happen that the sequence number can be changed because some packets takes longer route or other packets take smaller route. So that's why there may be a problem that the sequence order may be changed. So the original sequence order and the receiver sequence order will be different. In that case, what we will do in that case, in the receiver side, there is a logic present, that is the reassembly of packets, and through this logic, we will again reassemble the packets according to the sequence number. So that's how a packet switching works. And datagram packet works like this, that the message is divided into stream of packets, and the communication should be done in an order. Now, in this communication medium, there are different routers and switches are present for communication. Okay, so this is the datagram packet switching. The next type, that is virtual packet switching. The virtual packet switching is the logical connection that is established between sending and receiving devices. It is the logical connection. It is a logical connection that is established between sending and receiving devices. And all the packets travel through logical connection or virtual circuit. Means virtual connection is done in this virtual circuit packet switching. So that's how the virtual circuit packet switching works. Clear? The method or the mechanism of packet switching is clear. It is clear to everyone that how packet
Yes.
switching mechanism.
Yes, sir.
Okay, so this is the type of the packet switching mechanism. Now, what are the advantage of the packet switching? Now you see that it increase the bandwidth and reduces the transmission delay. Reduces the transmission delay means that the packets can be takes different routes. Packets taking the different route to reach the destination. So there the transmission delay didn't occur because there are no traffic. We can say there is no trafficking, no trafficking. So the packets can be take any of the routes. If any route is busy, then packet will take in the other route to reach the destination. So the packet will reach, anyhow the packet will be reached. So it reduces the transmission delay. So it is the advantage of packet switching. But some disadvantages are also present for packet switching. Now, what are the disadvantages? That the large amount of RAM is required. Now, for this communication for packet switching, the amount of RAM is required large because we are breaking packet here and the receiver side we are reassembling it. Means the packet which in the sender side, first in the sender side, we are dividing the packets. We are dividing the message into packets. So for this, a large amount of RAM required. And in the receiver side, what in the receiver side we are performing? In the receiver side, we again takes the packet and after taking the packet, reassemble that packet and makes it to that original message. So this for this process, the amount of RAM for storage purpose, it will require more, large amount of RAM is required and requires more processing power. Now, why it's require more processing power? Because it is we are dividing the original message first. We are dividing the original message into packets. So for there, this process, there is a process working. Next, the packet will take the different routes. So packets will for different routes, and again in the receiver side, it will go after that packet. We are reassemble that packets according to the sequence number. So it requires more processing power. That's why it is the disadvantage of the packet switching. So this is the last switching which is left over in the previous class. This is the switching techniques. So we have seen there are three switching techniques present: circuit switching, message switching, and packet switching. In circuit switching, what I will again recall that in circuit switching, a connection should be established. After connection establishment, we can send the, if the sender sends the data to the receiver, and after the work completed, then the connection is terminated or the connection is discontinued. In the circuit switching, in the message switching, what we have done, the message are stored in each and every devices that present in the communication medium. And in this, the whole message is the stored. And after what, go and policy, store and forward policy. For after that, it will be again passed to the next devices. And that's how the communication goes on. And in this, the circuit switching, the whole message is divided into packets, and the packets will take different routes in the communication media, and through taking different routes, it will reach the destination. But it may happen that some packets get first, some packet get takes more time. So it will be the some it will again, so it will unreasonable. So we have to, in the receiver side, we have to reassemble it. We have to reassemble it, the packet, according to the sequence number or the original packet when it's sent from the sender, according to that. So that's how the three switching techniques work. Clear? So this is all about the switching techniques. Okay. So now we will see the open system interconnection. The open system interconnection or the OSI model, which we have discussed. Now, in every networking devices, in every network devices or the layered framework for the design, this type of communication, this layered framework, OSI model is followed. It is a layered framework for a design of network system that allows communication between all types of a computer system. In all types of computer system present in the network, it follows this layered framework. If two communicating devices are present, then sender also follows this layered framework and the receiver also followed this layered framework. Means this layered framework for every system in the network and it follows this layered framework. Now it is a layered framework for the design of the network system that allows communication between all types of computer system. And in this system, 7 separate layers are present. So that means if two devices want to communicate, then device 1 or the system 1, it also has this 7 layered framework, and the system 2, this also has this 7 layered framework. Okay, so this layered framework is followed the design of network system, and all types of computer system followed it. These are the 7 layered separate layers are present, and each layer calls upon the services of the layer just below it. Means each layer that is present, it calls the service of its upper layer. It calls the service or of the upper layer. So the 7 layer, you have to take in mind, the 7 layer should be, the 7 layer which you will see will be according to the sequence. Always when there may be question asked in the exam that write the 7 layer. What are the 7 layer present in the OSI model? Always write according to the sequence. Always write according to the sequence. If you didn't write it according to the sequence, then it has no meaning. So you have to remind it. Okay. So the topmost layer present is the application layer. The topmost layer present is the application layer. Then after application layer, there is the presentation layer. After presentation layer, there is the session layer. And after session layer, there is the transport layer. And after transport layer, there is the network layer. And after network layer, there is a data link layer. And after data link layer, there is the physical layer. So according to the sequence, you have to remind that first application layer, then presentation layer, then session layer, after that transport layer, then network layer, then data link layer, then physical layer. Now I will show some shortcut tricks which we followed to remind this. We followed this for remembering purpose. We use this. Okay. So if you some shortcut tricks for remembering of the sequences, like if you use this sentence that all pupils seems to near Domino's pizza, then all the first letter, first write all the this sentence first letter first, and then from there you can write the layer's name. Okay, so first, if you remember this sentence, that all pupils seems to near Domino's pizza, and according to each word, first letter, write it first. Write it first. Then all first letter is A. Pupil first letter is P. Sims first letter is S. To first letter is T. Near first letter is N. Domino's first letter is D. And pizza's first letter is P. So now, after writing the first letter, you will automatically have in mind that first will be application layer, then second will be presentation layer. S means it means session layer. T means transport layer. N means network layer. D means data link layer, and P means physical layer. So according to that, you also use some own shortcut tricks also. But this, if you follow some shortcut tricks, then it is easy to remember according to the sequence of the layer. Clear?
Yes, sir. Yes,
So
sir.
that's how this कोई शॉर्टकट ट्रिक्स अगर तुम लोगों को माइंड में आते हैं तो उस शॉर्टकट ट्रिक्स के बेसिस में इसको माइंड में रखना, ठीक है। और जैसे इधर जो सेंटेंस हम दिखा है, इस सेंटेंस का हर फर्स्ट वर्ड हम ले लिए, ठीक है। हर फर्स्ट वर्ड पहले लिख लो, और फर्स्ट वर्ड लिखने से क्या है तुमको माइंड में चला आया। ए मीन्स एप्लीकेशन लेयर, पी मीन्स प्रेजेंटेशन लेयर, एस मीन्स सेशन लेयर, टी मीन्स ट्रांसपोर्ट लेयर, एन मीन्स network layer, D means data link layer, P means physical layer. So that's how the sequence should be maintained. Because whenever you have to write this question, then always write it in the sequence order. Otherwise, the number will not be given. So always write in the sequence order, either from top to bottom or bottom to top. Both can be followed, but either from top to bottom or bottom to top. This sequence can be followed. Okay. So these are the 7 layers. These are the 7 layers present in any of the communicating devices. For communication, each devices that is present in a network has this their own, and they followed it. So first we will know each layer working principle. So each layer, how each layer works, we will see one by one. So the first layer is the physical layer. The bottom layer. So physical layer is responsible for moving individual bits from one node to the next. It is responsible for moving individual bits in physical layer. We work on the bits, and these bits move from one node to the next. Now, what are the functions in the physical layer? The functions of a physical layer is to define the type of the transmission media used for communication between two devices. Means the two devices, there is a sender, there is a receiver. Okay. So sender has also this 7 layer present. Receiver has also this 7 layer present. Now, the physical layer of that, the physical layer will define which type of transmission media should be used for communication between them. Transmission medium means which transmission medium means you know that it is wireless or wired media. Whichever transmission media should be used between them. So physical layer defines the type of transmission media, and inside the transmission media, it is wired transmission or wireless transmission, or we can say it is guided or unguided. And inside this guided transmission media, you know that what are the types of transmission media used in the guided? Coaxial cable, twisted pair cable, then fiber optic cable. And in wireless, what are we use in the wireless? In wireless, we use infrared, then microwave, then radio wave, all this. So what type of transmission media should be used? It is defined by this physical layer. It also defines the type of encoding to be used. Now the data encoded in the 0-1 format. So if sender wants to send the data to the destination or the receiver, then it will encode it. And how it will encode? It will encode it into the 0-1 format. It will be encoded in the 0-1 format. So it defines the type of encoding to be used, and the data are encoded in the 0-1 format. So through 0-1 format, the communication between this sender and receiver will be done. and it defines the data rate or the duration of the bits. Now, what is the data rate? Data rate means the number of bits, the number of bit sent per second. So per second number of bits will be, how many number of bits will be sent? It is defined by the physical layer. Physical layer defines that how many bits can be sent from sender to receiver per second. It also has the function of the physical layer is also that it defines the data rate or the duration of bits. And the synchronization of bits, it is another function is the synchronization of bit. That means the sending side and the receiving side sequence number of bits must be same. So what we have seen in the packet switching, that the sequence number should be same. So that means the synchronization of the bits, that the sending side and the receiving side sequence number of bits must be same. And line configuration between them. Line configuration between them means it how is what will be here, that it is the multi-point. Physical layer defines which type of configuration should be used, point to point or multi-point. Means it is the dedicated link or the link it is shared by the all the PCs. It's shared by the all the PCs or the systems. So what type of line of configuration should be used, point to point or multi-point? This is also decided by the physical layer. Physical layer decide this. And which type of physical topology used for the communication? Now, how many types of topology present? 5 types of topology present: bus, ring, star, then tree, then mesh. So what type of topology? In this 5 types, the topology present, in which of this will be used for the communication? It is defined by the physical layer. And the transmission mode. What type of transmission mode will be used? You didn't know there are 3 types of transmission mode present: simplex, half duplex, and full duplex. So what type of transmission mode? Either it can be simplex, or it can be half duplex, or it can be full duplex. Which type of transmission mode should be used? It is also defined by the physical layer. Now this transmission media, which I have tell that simplex, half duplex, and full duplex. Now the simplex means, what is the simplex? Simplex means it is the communication channel that sends information in one direction only. Like it is the communication channel. Simplex is the communication channel that sends information in one direction only. Example, like you are writing in the something through keyboard. Then you are sending the information to the PC. It is possible that from PC, you through keyboard, you are seeing you are only sending information in one direction. You are writing through keyboard, and keyboard is sending messages to your systems or the signals that into your systems. So, and in monitor, do you write in monitor? You only from monitor you can see the things. So one-way communication. This is the one-way communication. That's why simplex is basically called that sends information in one direction only. It is a communication channel that sends information in one direction only. That from keyboard, you write something. And so that message goes to the system. Is it possible that from system through keyboard you get some message? It is not possible. And also in the case of monitor, in monitor, through monitor you see the things. But is it possible that you done something into the monitor? It is not possible. So that means one-way communication. So it is the communication channel that sends information in one direction only. That is the simplex. Now, what is the half duplex? In half duplex, sender can send the data and also receive the data. Sender sends the data to the receiver, and Receiver also sends the data to the sender. Both way communication is possible, but one thing is both way communication is possible, but not at the same time. So it is called the half duplex, is called the bidirectional. That means two-way communication. So in half duplex, two-way directional communication, sender to receiver, the message can be transferred from sender to receiver and receiver to sender. So both can be possible, but not at sorry, but not at the same time. Now, example of this is if you see in the traffic sergeant, if you see any traffic sergeant, the traffic sergeant is working with a walkie-talkie. The traffic sergeant is using some walkie-talkie. So in walkie-talkie, what is done? The in walkie-talkie at same time, sender or receiver cannot send the data. Sender and receiver can communicate with each other through sending data, but not at that same time. So when in this, you can see in walkie-talkie that where the in the traffic sergeant uses this, that at first, if you see, if anything are communicated, they are only listening that. And after completing it, he or she can transfer the message to the other person, who is at that time will be the listener. So wait for some minute. So what we are talking about, that in the half duplex, the sender can send the data and also can the receive the data, but not at the same time. So it is the two-way directional communication, but not at the same time. It is the, what is example of this? Example of this is the walkie-talkie. That when, if you see that when there are two devices present, when A is sending, B will only receive. When A will send, B will receive. That means when one is sending, then other device must only receive. And here in the next, after receiving B receive, it sends now. In the next time, B is sending and A is receiving. So sending and receiving both can be done, but not at the same time. And the example is the walkie-talkie. And for full duplex, what is the full duplex? Sender can send data and also can receive the data simultaneously. In this full duplex, both can send the data simultaneously. So it is also a two-way directional communication simultaneously. Example, the telephone communication, that you can both talk simultaneously. So full duplex is the, for full duplex, example is the telephone connections. Okay, so physical layer defines which type of transmission mode, either it is simplex, or it will be half duplex, or it will be full duplex. Which type of transmission mode should be used? It is defined by the physical layer. So if you observe it, if you observed very carefully, then you can see physical layer basically deals with how to transmit data. Basically, it focuses on about the transmission of data. You see first, what it defines the sorry, it defines as the transmission media. So in difference in the transmission media. So basically it deals with how to transmit. Okay. So it is clear.
Yes, sir.
So it's basically what it is doing. It is basically deals with the transmitting of data. So how the transmission can be done? Physical layer only focuses about this, because all of the function you can observe, all of the functions you can see, it is always focus on the transmission part. You can see what type of transmission media, how the data should be encoded, how the data rate, number of bits can be sent per second, synchronization of the bits, line configuration, which should be used for communication, and which topology should be used for communication, and what type of transmission mode should be used. Now, all of the functions, you can see, all of the functions are related about the transmission. So from here, we can say that physical layer is basically deals with how to transmit data. So physical layer basically deals about it. Okay. So both sender and receiver has this physical layer present in their layered framework. So, and in this physical layer basically deals with how to transmit the data, how to transmit the data. So this is the last bottom of the layered framework, that is the physical layer. In the above of the physical layer, there is present what? There is a present data link layer. In the above of the physical layer, that they are present data link layer. Now, this data link layer basically transfers